Here we are at Rocking the Boat, and this is the Arduino-based tide tank project. The way the system works is there's that big blue sump and there's a pump constantly running, filling this fish tank up. I think there's a crab hanging out in there somewhere. And the overflow from that fish tank, which is constantly overflowing, it's constantly being filled by a pump, runs down into this smaller tank. This is the tide tank. And it's tidal in the sense that that water level is exactly calculated to be at a level proportional to the local tide. We happen to be in Hunts Point in the Bronx, and NOAA has a weather station at Kings Point, and this is coordinated with that weather station. The way the system works is there's a float sensor. You can see there's that little buoy at the end of this long arm, and as the buoy floats and sinks, it actually turns a potentiometer in this little box. That potentiometer gets fed into a phone line, which goes to the main control box. Also attached to the control box is this servo motor. The servo motor is mounted on the side of the tank, and at the end of the motor there's that stick, and that's actually operating a flap valve. And you'll hear little kicks as the motor operates in little increments of about 10% of its total range. So how does it actually work? Well, here is the Arduino. It's in a plastic box for safekeeping. What it says is Kings Point equals 6.22 feet. That's the current tide height at Kings Point, as reported by NOAA. This uses NOAA's great API to pull that data every 6 minutes. That 2 means it's not going to pull NOAA for another 2 minutes. I don't want to be bothering them more often than is necessary. And that 6.22 feet translates into 58% of the tank. The low water mark of the tank is actually at this mark right around here, and the high water up there. So if that's 0, if that's 100, 58 is where the water should be, because that's what the tide is. If the tide was 10 feet, it should be at 100%. If it was -1 foot, it should be at 0%. That's because 10 and -1 is about the biggest range that we get at that station over the course of the entire year. And by the way, that's measured, that's MLLW is the data, and that's mean low water level. And that V equals 0%, that is the valve. 0% means totally closed, and you see it twitching. What it does is the float sensor takes water height readings 5 times a second. Every second it averages those, and this data becomes that first number there. It's 58 right now, which means it's exactly where it wants to be. If it goes down to 57, you'll see that this will tick in the appropriate direction. Too much water, that means you have to open up the drain. Too little water, you have to close the drain. So that's the system. It's been working so far in our testing, and the code will be online, so you can implement it if you want. It's all Arduino and it's all open source, so go ahead and enjoy.